Hello students, and welcome to Module 7. This lecture video covers Chapter 6 in the Adams and Lawrence textbook, and it goes beyond descriptives, how to make inferences based on your sample. Chapters 4 and 5 covered off the idea of what a descriptive statistics are. And now we're going to actually get into what inferential statistics are. Can we infer from the research that we've done anything about the population? Or how do you go about getting data so that you can make accurate inferences about a population? So then we are defining parameters instead of statistics. We're talking about mu instead of the mean, and we're talking about sigma instead of standard deviation. Don't kill yourself on this kind of stuff, because this is really part of PAD4704. So there's a lot in this chapter that we're not going to get into in depth, but it fills in a few of the holes which we need in order to move on with our research projects for this semester. An inferential statistic is based on probability theory. So tossing a coin, probability theory says that a coin, unless it's weighted, if you toss it 100 times in the air, roughly 50 times out of that 100 it's going to come up with heads. And so if you do it enough times and enough times and enough times, then you should get that normal curve that we talked about, where 50 is the mean, or in this case an inferential statistic would be giving you mu. So that's what probability theory suggests. Based on the pattern, we can establish how probable certain results are. Hypothesis testing comes out of this. So hypothesis testing is the process of determining the probability of obtaining a particular result or set of results. The key question is the outcome unusual? So if we have a probability theory that says 50 times out of 100 on average you should have heads and tails on a coin toss. So 50% of the time it should be heads. If you come up with the, as I mentioned in the textbook, if you come up 10 heads out of 100 coin tosses, then it would be unusual. Then that would be highly unusual. So that's what hypothesis testing comes out of, is the outcome unusual, and that's what we're after. In order to decide whether an outcome is unusual, we compare it to a theoretical sampling distribution. And it's important, theoretical. We're talking about a theoretical sampling distribution, and that's the idea of setting up a null hypothesis versus an alternative hypothesis. So the null hypothesis is this prediction that there will be no difference between the groups. And this is what assignment number 3 is going to get to, and we're going to actually have you do your own null hypothesis and alternative hypothesis for assignment number 3. The alternative hypothesis is a prediction of what the researcher expects to find in a study. In hypothesis testing, we compare our results to a theoretical distribution in which the null hypothesis is true. Theoretical distribution. Okay, we don't actually go out and get this distribution, but we use probability theory to say this is what should be the case based on probability theory. And so if that comes out to be the truth, and if you support the null hypothesis, then that's what you've done, is you've said, yes, this theoretical hypothesis still holds true. So you're setting up something that you want to, as they call it in hypothesis testing, a straw man that you're trying to push down. So you set up this straw man, and then you try and push it down with your hypothesis testing. So you want to word your null hypothesis in such a way that it is likely going to be true. And that way, if your alternative hypothesis becomes true, then you have knocked out your null hypothesis. Or in other words, if you set up this straw man and your alternative hypothesis turns out to be true, then you've knocked over the straw man, and all of a sudden what you set up as your null hypothesis has been shown to be wrong. And that's the importance of hypothesis testing, is in all likelihood your null hypothesis should be right, and when you fail to support your null hypothesis, you're moving forward in research. Your experimental scientific methods are moving you forward in a new direction. As a researcher, you should always plan your statistical analysis before you conduct your study. If you do not consider how to analyze your data as you design your study, you might collect data that cannot be analyzed or that will not adequately test your hypothesis. We're going to walk you through this process in assignment number 3. When you are thinking of your variables, remember this is from this is that frame that I gave you numerous times when I was talking about your diagrammatic models when I returned assignment number 1. So that discussion video for the return of assignment number 1 went through this numerous times. So I'm not going to go spend any more time on it now, but I'm going to go through this again when I come up with how to do assignment number 3. Remember all of these models. These are all of the models which came out of assignment number 1. So these diagrammatic models were all in the aid of considering how your data, so as it relates back to this frame here, this is from Adams and Lawrence, page 189. All of those models which came out of assignment number 1 were all about how to analyze your data as you design your study. So if you haven't got a good model, you haven't designed your study yet. If you're going forward with the design of a study without a model, you're going to end up collecting data that cannot be analyzed, and you will not be able to adequately test your hypothesis. So it's important to get this designed. So assignment number 3, we're going to do another diagram, and now that you've done assignment number 1 and got this feedback, you should be able to have no trouble at all doing a diagrammatic model for assignment number 3. So once again, we return to this theoretical sampling distribution. If we're going for 95% certainty, then we've got a 2.5% region of rejection in either one of the tails on a two-tailed hypothesis testing. The theoretical distribution, once again, this is that idea that we referred in the last chapter about 1 standard deviation, 2 standard deviations, and 3 standard deviations from the mean on a normal distribution. And so the hypothesis testing is based on the idea that the results that fall within the region of rejection are unusual. They are likely not due to chance alone. So if your hypothesis testing puts you in that region of rejection, then you are able to not support the null hypothesis. Results within the region of rejection are said to be statistically significant at whatever criterion set for the p, the probability value, which is and a criterion of probability less than 0.05%, which is your 95% certainty, indicates that there is less than a 5% chance that the results were due to chance alone. So if you end up in that region of rejection, based on good theoretical, good research design, then you have statistically significant results. One-tailed or two-tailed hypothesis. Two-tailed is non-directional, so you can reject, and we'll talk about this in assignment number 3. A hypothesis stating that results from a sample will differ from the population or another group, but without stating how the results will differ. So it could be lower or it could be higher. And it doesn't really matter the way you worded your hypothesis. If it falls outside of the 95% certainty probability area, then you can reject, you're in the region of rejection. It doesn't matter on which tail. If it's only a one-tailed hypothesis, then you can put that region of rejection at 95%. So you've got a larger region of rejection because 95% certainty applies to everything else, including the tail. And so you have a 5% region of rejection on the one tail, whether it's the top tail or the bottom tail. So the steps in hypothesis testing, how you do this if you're actually going to do the whole experiment, is you state your null hypothesis first. Then you state your alternative hypothesis, then you define the sampling distribution in the region of rejection, your criterion level. Then you collect the data and you compare the results and you decide whether to reject or retain your null hypothesis and consider the possibility of error in your results. So that's what we're going to do. Type 1 and type 2 errors. The type 1 error is the probability of rejecting a true null hypothesis, defined by the probability of the significance level of your findings. Read in your textbook and understand what that is. It's not going to be on any exam. I don't ask you anything about a type 1 error or a type 2 error. But type 2 error is the probability of incorrectly retaining a false null hypothesis. And it tells you how to, in designing your research, how to compensate for and plan for the possibilities of either type 1 error or type 2 error. And this table here is part of that explanation here, so I'm not going to get into that in the video because it's not going to be on a midterm. Once again, how to reduce the type 1 error, how to reduce a type 2 error. This is in your textbook and you can go back and review that if you haven't. But like again, it's not going to be on the test. This is an interesting table. Practice 6.3 is something which it walks you through this rejection and retaining your hypothesis in the decision-making process. And can you enter the information? And so this talks about the Zeifel and Bay study from 2005 that she talks about in application 6.2. This may help you in doing assignment number 3. So mark this page in your textbook It's marked within the assignment, and it's within the pages designated by assignment number 3 that you'll need to go through. And you may want to actually work through this as you do assignment number 3 and follow this modeling through this process here. This is the answer that's given in the back of the textbook for you. And so you can compare the practice exercise against the answers in the back of the back appendix of the textbook, and to see why they came up with a conclusion that they can reject their null hypothesis. Interpreting the results, we're not going to cover this at all. One sample t-test, we're not going to get into this at all. Once again, this is PAD4704 material. More t-test material, more on the t-test, and interpreting the results, statistical significance. So these sections of the textbook, if you read through them, you're good. I hope you're familiar with them, but you don't need to work on memorizing them or retaining that material for the midterms, because we're not going to get into it. Now to get into assignment number 3. I pulled assignment number 3 from a story that was dating back to 2007, since I think 3 or 4 of you indicated on assignment number 1 that you had interest in abstinence-only sex education, which got me thinking about this, and it's an excellent example of how to build a hypothesis from secondary data. So in 2007, after 10 years of having abstinence-only education in the United States, funded with enormous amounts of money, $1.5 billion had been spent on abstinence-only sex education since 1996. And so the research group went in and did a longitudinal study over this 10-year period to find out whether it was successful or not. And this headline here says it all. Because it was a Republican government in power in 2007, it was still a Bush administration, and he had been a huge proponent of abstinence-only education from the time that he was in office. And he had spent, like I said, $1.5 billion had been spent over a decade on this. And so the Republicans were very embarrassed by this study, which came out, done by a third independent agency, Mathematica Research. And so they released it late in the day on a Friday. So if you have bad news in politics, you always release it late in the day on a Friday, and then by Monday morning the news cycle has worked its way through and everybody else has new news to talk about Monday morning. So they're not going to talk about this bad news that really reflects poorly on the government. And this one here just happened to be Friday the 13th when they released this study. And so they tried to bury it because it said basically that they had spent $1.5 billion and had absolutely changed nothing about the behavior of young adults. They were still as sexually as active as any other teens. And what they had in this study, in order to qualify for Title V funding, there were 8 points that you had to match, 100% match on all 8 points in order to get Title V funding. You had to show that your program was going to have as its exclusive purpose teaching the social, psychological, and health gains to be realized by abstaining from sexual activity. Number 1 goal, you teach that there are a lot of benefits coming from abstaining from sexual activity. Number 2, you teach abstinence from sexual activity outside of marriage as the expected standard for all school-age children. This is the standard in America. This is what they need to think and have taught to them. And so there's all of these points all the way down here. These are what you have to do. And what they did not say in there, in the small print down at the bottom, there was this caveat that said, you know what, if you do all of those other 8 things, there's still one thing that you cannot do and you cannot include under any circumstance, and that is the idea that you are prohibited from discussing methods of contraception, including condoms, except in the context of failure rates that could lead to an unwanted pregnancy. So you can do all of these other 8 things that are proactive measures that you had to agree to, all 8 of them, but you had to also agree that you would never ever talk about contraceptives except for the fact that they can fail and cause an unwanted pregnancy. So in this 65 page study that came out from Mathematica Research, Mathematica Policy Research Inc., out of their 60 some odd pages and probably another 60 pages in appendices, they put one little paragraph in there that said, this is the paragraph on page 60, that as a result of not allowing anybody to talk about a contraceptive, they could not talk about a condom, in how it prevents sexually transmitted diseases. You could not even mention sexually transmitted diseases except for the poor health outcomes. You couldn't even talk about, in the context of teaching these children that having sex and having sex outside of a monogamous marital relationship. You could tell them that any kind of sex outside of a monogamous marital relationship could result in a sexually transmitted diseases, but in the next breath you could not tell them that if they ever did, that this is how you can prevent an unwanted sexually transmitted disease. So these students for 10 years in the United States, in 27 out of 50 states, were teaching abstinence-only education without once even being able to mention that a condom prevents a sexually transmitted disease in a formal education setting. And so that's for your 20 points for this assignment, for assignment number 3. What I want you to do is I want you to write a null hypothesis and an alternative hypothesis about the impact that Title V funding had on the spread of sexually transmitted diseases, especially HIV. So there are several steps that we're going to have you go through here, and as you download the assignment number 3 Word document, the PDF document from the Blackboard, you will have all of the detailed instructions about this, including everything that shows up here. But I want you to start and do this in a very ordered sequence. I first want you to do your diagrammatic model. I need you to tell me what you're, in this model, before you even try and write a hypothesis. Remember, this is research design. And if you design your research poorly, then you're going to have unworkable research parameters. So I need you to figure out what you want for Y in this model. I want you to have an independent variable that is very clearly stated, and I want you to have at least one intervening variable, maybe 2 if you want them, but at least one intervening variable. So I want you to follow this model here and have your dependent variable, independent variable, and an intervening variable. Start with some kind of a diagram that talks about and gets me to the point where you understand what Title V funding did, what kind of an impact Title V funding had on the spread of sexually transmitted diseases. Operationalize your idea. Okay, so it's important to note, and how when I talk about operationalizing your idea for this hypothesis that you're going to try and design, you have to write a null hypothesis and an alternative hypothesis, but before you can write them, you have to have an idea in your mind how to operationalize this model. So we drew the model, and now you have to operationalize the model. And it's important to note, when you think about operationalizing this research program, that 23 states outright rejected Title V funding. They recognized it as an ill-advised program that they wanted no part of. So notably, none of these states were in the South, and this is your big hint. Young people in these 23 states had normal sex education. So what does that tell you? That's a very important big hint to help you operationalize this research. You have 23 states where things carried on as normal, and 27 states where they went off on this ideological wild goose chase. So I need you to then define your study population and your unit of analysis. These are worth points as well, as I've mentioned in the PDF file that you're going to download. Each one of these has points attached to it. Your study population, naming your study population has points attached to it. Naming your unit of analysis has points attached to it. And that should come very, very easily if you have diagrammed a good model. After you're done that, you write the null hypothesis and your alternative versions of your hypothesis. Remember to go to practice 6.1 if you need help in doing this, because the answers are here in the back of the book in the appendices of the textbook. This practice 6.1 asks these questions and gives you the answers in the back of the book. That's on page 191. So you can go there if you need help writing your null and alternative hypotheses. From page 190, very, very important to this assignment. The null hypothesis is important to state because that's exactly what we test in the study. Okay? We are testing the null hypothesis. That is what's going to fall in the normal circumstances based on your theoretical distribution. A study should always be designed to find a difference between treatments, groups, and so on, and thus to reject the null hypothesis. And most importantly, many novice researchers will mistakenly design a study to support their null hypothesis. You state the null hypothesis based on what you're testing, but then you actually design the study to try and disprove what you're testing. So you're testing this, but you're designing a study to try and fall in the regions of rejection at the either one-tailed or two-tailed. So many novice researchers will mistakenly design a study to support their null hypothesis, which means that if you do this, they will try to show that there is no difference between their sample and the population. Such studies will not further our knowledge because we do not learn anything new about the variables of interest. If you design your study to test the null hypothesis, all you're doing is saying, yeah, my study supported what we already knew. So you didn't gain anything. So you try and state what you already know, and then you design a study to prove yourself wrong. This is what they mean by the straw man. I love this cartoon because, as you know, I'm an atheist, and so on the end of this box here, the Acme straw man kit, the easy straw man kit. As you, if you watched the Roadrunner show, when I was a kid, Roadrunner was big. Every Friday at 5 o'clock we would watch the Roadrunner, and the Coyote would always order from Acme all of these kits. So this is what this builds on. This is the easy straw man kit that you can order, and it is appropriate for creationists or politicians age 2 and up. And as it states here, step 1, and this is about spurious correlations, because if you want to design a study where you already know the results, if you want to design a study where the results will prove something that you already believe in, then you can design a straw man null hypothesis that works for you. And this is how to do it. Step 1, assemble a straw man using the distortion, misrepresentation, and simplification tools enclosed. Step 2, knock straw man down. And step 3, claim victory, hours of fun guaranteed. So this is how you do bad research as well. If you already go into research knowing the results that you want to get out of that research, you build a straw man based on distortion, misrepresentation, and simplification. And so you have to watch out for that. If you want to design good research, you make sure that you have a good, clear null hypothesis in mind, and then you design the research to try and disprove what you've got in mind, and base it on good research without any spurious correlations. Last of all, there's one point available by naming whether your null hypothesis or your hypothesis have been written for one-tailed or two-tailed testing. At this point, I don't want you to even think about this one-tailed or two-tailed thing until the very, very last thing, until everything is done. Because it doesn't matter to me whether you designed a one-tailed or two-tailed hypothesis. I want you to be able to, at the end of the assignment, go back and look at it and say, did I word this in a way where I'm testing for a one-tailed or a two-tailed result? Simple analysis. Don't change anything. Just look at it, read it, and say, is this one-tailed or two-tailed? That's all I need you to do. And then you're done. Thanks so much, and send me an email if you have any questions.